We're going to look now at solving triangles. And solving triangles just, again, brings together the skills that you have in terms of using the Pythagorean theorem, using right-angle trigonometry to solve for an unknown side length, and using right-angle trigonometry to solve for an unknown angle. So when we're solving for a triangle, it means we have to figure out the length of every single side, so the length of all three sides, and we need to figure out the value of every single angle. Okay, and so to do so, there's really three steps that you want to go through. You want to label the sides and the angles of a triangle. And so to do that, you want to try and follow this model that we have here on the right-hand side. And this is going to be really important for when we extend our knowledge on trigonometry in the next unit. But in this instance, you'll notice that the three angles, the three vertexes of the triangle are all labeled with capital letters. So capital A, capital B, capital C. You'll also notice that the side that is across from that angle, okay, is the same letter but in lowercase. So for example, for angle A, the side opposite angle A is small case a. The side opposite angle B is small case b. And the side opposite angle C is small case c. Okay, that's going to be something that we come back to over and over and over again when we do our second unit. And so I'd like you to get into the habit of labeling the lengths of your sides as the same letter as the opposite angle. Okay, so again, you want to label your triangle first. That's the first priority. So in this instance, we have a triangle that we want to try and solve. Okay, so in this case, we know two side lengths, and one angle. We know that there's a 90-degree angle in there. So we want to try and figure out, well, what are all the side lengths? So let's first off start by labeling the three sides. So I know this is going to be side K. This is going to be side J. And the 40 is going to be side L. Okay, so that's just the name of the three sides. Okay, so first thing that we want to do is we want to see, can we use the Pythagorean theorem if possible? And in this first case, we can figure out the length of K, okay, side K, this piece right here, by using the Pythagorean theorem, because we actually have the length of two of the three sides in a right angle triangle. So again, you'll remember that we've got the Pythagorean theorem formula is a squared plus b squared is equal to c squared. Okay, well in this instance, our c value is k because this is our hypotenuse. Okay, that's our hypotenuse. It could also be known as the c value. Okay, and so I'm going to substitute in my value there, which is 50, so 50 squared. My a value, again, doesn't matter which is the a or the b value, so I'm just going to call this a, and I'm going to call this side b. Okay, so my a value is 40, so we're going to do 40 squared plus b squared, or actually I'm going to call that side k squared. Okay, so I'm just going to substitute k in for b. It's the same thing. So now what I want to do is I want to solve this. Okay, so I need to get k squared all by itself. So what I can do is I can go, I want to simplify what I can, so I'm going to do 40 squared. So 40 squared is 1600 plus k squared is equal to 50 squared, which is 2500. I want to get that k term all by itself, and so to do that I actually need to remove the 1600 from the left-hand side of the equation. So to do that, I do 1600 plus k squared minus 1600. And if I've done that to the right-hand side of the equation, or sorry, to the left-hand side of the equation, I must also do that to the right-hand side of the equation. So I'm actually going to subtract 1600 from both sides. Let me try that again. I'm going to subtract 1600 from both sides. So what this means is that I'm left then with k squared is going to be equal to 2500 minus 1600, which should give me 900. Okay, and now I got to get that k value all by itself. To get the k value all by itself, I have to do the opposite operation of squaring k. So the opposite operation of squaring something is to do the square root. So I'm actually going to take the square root of both of those values. And so that means k is going to equal 30. Okay, so now I've solved for the length of k. So I know that k is 30 units long. So that's great. I've solved for the length of all three side lengths. Now I got to figure out the angles because I don't know what the angles are. So let's pick an angle to solve. And so let's solve for angle x because that's given to us right here. Okay, so I want to try and solve for x. So solve angle. Let me try that again. We want to solve for angle x. Okay, so we know that we've got an opposite. So our opposite side length for angle x is 40 units long. We know the hypotenuse is 50, and we also know the value of the adjacent for angle x. The adjacent is 30. Okay, so we can choose any one of the trig ratios because we have all three of them. So because we have the length of all three sides, we can actually use any one of the three trig ratios. So if I wanted you to show that, I could do so ka toa. Okay, and in this case, I'm trying to figure out the angle. So I'm looking for the angle. And what pieces of information do I have? Well, I know the opposite, I know the hypotenuse, I know the adjacent, the hypotenuse, the opposite, and the adjacent. So it honestly doesn't matter which of the three trig ratios you choose. So for simplicity's sake, I'm just going to take the sine ratio. Okay, you could take the cosine ratio or the tan ratio. It honestly doesn't matter. Okay, so I'm going to use my values and my numbers and substitute them in. So I'm going to do, I know sine of x is going to be equal to the opposite divided by the hypotenuse. So I'm going to do sine of x is equal to my opposite side. Right here it's 40 up at the top there. And I know that my hypotenuse is 50 units. So then I've got sine of x is equal to 0.8 because 40 divided by 50 is 0.8. And then I'm going to actually go through and solve for x. So I need to do my inverse sine function to both the left-hand side and the right-hand side. So I'll quickly write that out just so we can see it. I've got sine to the negative 1 is equal to sine of x, which is going to equal sine to the negative 1, 0.8. Okay, and so x is then going to equal whatever the inverse sine of 0.8 is, which is 53 degrees approximately. So 53 degrees. Okay, so now we know what the value of angle x is. We know what the value, we know that that is now 53 degrees. And so now we're trying to figure out, well, what's angle k? So let's go through and let's solve for angle k. So let's solve for angle k. So we've solved for side length k. We have solved for angle x. Now we're trying to solve for angle k. Now, what's really important here is what piece of information do we have? Well, we actually have two of the angles of a triangle. Okay, and we know from our earlier experiences that the sum, when you add up all three inside angles of a triangle, it equals 180 degrees. So we could say that angle J plus angle K plus angle L are all equal to 180. Okay? So what we do now is we're going to substitute in our values for both J and L because we know what those are. Okay, so J is 90 degrees. We don't know what K is. That's what we're trying to figure out. And angle L we just solved to be 53 degrees. Okay, and so those three numbers are going to add to 180. So I want to figure out, well, what's K going to be? So if I want to figure out what K is, I have to actually get rid of the positive 90 and the positive 53 that's on the left-hand side of the equation. So I'm going to do 90 plus K plus 53. And I'm going to do my opposite operation. So I'm going to actually subtract 90, and I'm going to subtract 53 from the left-hand side of the equal sign. And that's going to leave me with 180 minus 90 minus 53. Okay? So in the end, it's going to leave me as K is equal to 180. So if I take 180 minus 90 minus 53, K is going to equal 37 degrees. Okay? Because that 90 and that 90 canceled out, and that 53 and that 53 have canceled out. Okay? So K therefore must be 37 degrees. So now I've actually gone through and I have solved my triangle. I know the value of all three angles, and I know the value of all three side lengths. Okay? So by combining what you know about the Pythagorean theorem, using trigonometry to solve for an unknown side length, using trigonometry to solve for an unknown angle, as well as the knowledge that three angles inside of a triangle all add to 180 degrees, you can solve any right angle triangle, provided that you're given at least three pieces of information, okay, or at least a couple of pieces of information to start off with.